Hey beautiful people, welcome to my channel. My name is Busisiwe Dlamini Harori, the campus principal. If you haven't subscribed already to my channel, please pause the video and click on the subscribe button there at the bottom, and also click the notification bell so that every time when I upload a video, you will get a notification that is a new video uploaded so that you can be able to check it out. So today we are going to do preparation of solution part 4. So what we are going to do today, we are going to calculate or prepare our solutions using molarity. But before we get there, I want us to start with the basics, which will be to calculating the molecular weight. So basically, what is this molecular weight? So molecular weight, it is the sum of all atomic masses of the atoms that are in a molecule. So to be able to calculate molecular weight, you need a periodic table of elements. So this is where you'll be able to get the atomic masses of those different atoms that will be there in that specific molecule that you'll be calculating the molecular weight for. So what I did now, I've taken just the two elements from the molecular weight. I've written them there so that you can be able to see in a bigger picture. So the first element that's there in the molecular weight, which is hydrogen, that is why it has number 1 there on top, because this it means is the element number. And the H will represent the symbol, and that number there will be the atomic mass. So sorry, all the elements in the periodic table will have the element number, the symbol, and the atomic mass. But for us to calculate the molecular weight, we just need the atomic mass. So let's do an example. So we'll take water as a molecule, which is H2O, and calculate its molecular weight so that you can see how do you go about doing this. So there's H2O. So like I said, molecular weight is the sum. So it means we'll be adding. So hydrogen's atomic mass, it is 1,01. You can round it off to the whole number, which will be 1. So which is going to be 1. But now we have 2 atoms of hydrogen. Then it means we must multiply this atomic mass by 2 so that it can represent what it's there in that molecule. Plus the atomic mass of oxygen, which is 15,999. Then as well, you can be able to run it off to the next whole number, which will be 16. So when you put this into the calculator, which will give us a result of 18 grams per mole. So it means in each mole, we always have 18 grams. So basically, that's how it is. That's how you will calculate the molecular weight of any molecule that you can come across with. The only thing that you need, it will be your periodic table. Then you just look at the atomic masses, you add them together, and then voila, you will have your molecular weight. So now, since we do know how to calculate the molecular weight, then we can move over to molarity. So molarity, basically in its definition, it is the number of moles of solid dissolved in a liter of solution. And there is 2 formulas that you can use to be able to calculate molarity. But today in this video, I'm only going to show you one. If you are interested on the other one, you can please put your comment there that you are interested to see. Then I will send and make time that I make a video using that other formula so that you can be able to see how you will use that other formula as well. So the formula that we are going to use today is this one, whereby your molarity will be equals to grams per liter divided by the molecular weight. So that MW will represent the molecular weight. So let's have an example so that you can see how we can use this formula. So let's say we get a question that says we must calculate the molarity of a solution that contains 60 grams per liter of sodium hydroxide. So basically that's what we are given. It's that solution. So now we need to get the molarity of this solution. So what we will do, it will just be to substitute into the formula. And again, what is very important is that you must make sure that before you substitute into the formula, you have the correct units, because you cannot, it will be illegal for you to substitute any unit that is different from grams per liter and put it here. So if you get your mass as milligrams per liter or deciliter or something like that, you must just make sure that you convert it first before you put it or substitute it into the formula. So at least now we are lucky, our mass is in grams per liter. So we're just going to put it in as like that, which is going to be 60 grams per liter over. And then now we need to calculate the molecular weight for the sodium hydroxide so that we can be able to substitute it there. So we have sodium with an atomic mass of 23, oxygen is 16, and hydrogen is 1. So what you will do now, it was just to add up all those atomic mass. So all of these, I got them from the periodic table. Which will give us a molecular weight of 40. Then you're just gonna say 60 divided by 40, which is going to give us 1,5. Then it means the answer to this question is 1,5 moles. Or you can say it's 1,5 molar, or you can put in M like that to represent your unit. And voila, you were able to calculate molarity. But like I said, we are preparing solutions, so we can be able to use this formula by rearranging it so that we can be able to prepare our solution, so that we can know how much solid we need to either dissolve, weigh, measure, so when we are preparing a specific solution. So, which means now this is the original formula, but if we were to rearrange it, we can also use it like this, whereby grams per liter is equals to molarity multiplied by molecular weight. So it means this formula, you will use it every time when you are asked to prepare a specific solution and you are given the molarity. So they can say to you, prepare let's say a sodium hydroxide solution. So prepare a 2 molar sodium hydroxide solution. So you are getting a question like that. So what you need to, because now you need to prepare an actual thing. So it means you need to be able to determine how much of sodium hydroxide must you use to be able to prepare a solution with that specific concentration. If you can remember, moles, it's another way of expressing concentration. So it means now in this case, you are given the 2 molar, you will just substitute the 2 molar there, multiply by, you will calculate your molecular formula like we just did. So we did find that the molecular weight for sodium hydroxide is 40. Then it means at the end you're going to get the answer of 80 grams per liter. And if you are not being asked to prepare a solution with a specific volume, so basically what it means is that you're going to leave it there. You don't have to go any further. So it means for you to be able to prepare a 2 molar solution, you are going to dissolve 80 grams of sodium hydroxide into a liter of distilled water to make a 2 molar solution. So that's where you're gonna leave it. This is your complete answer on how you are going to prepare a 2 molar solution, because they didn't give you a specific volume. So now let's do an example whereby you are given a specific volume so that you can see how are you gonna go about that. So now let's say they're telling you that you must prepare a 300 mils of a 2 molar sodium hydroxide solution. So the first step will still be the same. So it's still going to be grams per liter is equals to molarity multiplied by molecular weight, which will be 2 multiplied by 40, which at the end gives us 80 grams per liter. But now we can't leave it here like we did with the previous one, because now they are telling you specifically they need 300 mils. So they don't need a liter. So you can't prepare that much because that's not what you need. So what you are going to do now in this case, you need to do a ratio and proportion so that you can get the grams that you need to weigh for a 300 ml. So already you know that if you want to prepare a liter, so if we convert a liter to milliliters, what do we get? We get 1000 ml, if you can still remember from the conversions. So we're going to say, okay, I have 80 grams, and with 80 grams, I will dissolve it in 1000 milliliters, which is a liter. But now, I don't need for 1000 milliliters. I only need for a 300 milliliters. But now I don't know how much of the grams of sodium hydroxide must I weigh. So now you're doing ratio and proportion, then you cross multiply, then you're going to have x 1000, which will be equals to then 80 multiplied by 300, which gives 24,000. And then as we did previously, we know that we don't need x 1000, we only need 1x. So what we will do, we will divide by 1000 so that 1000 can cancel 1000 and we are left with x, which will be equals to, and remember, always what you do on the left hand side, you must do on the right hand side. So it means on the right hand side as well, we're going to divide by 1000, which we're going to end up with an answer of 24 grams. So it means to prepare 300 ml of a 2 molar sodium hydroxide solution, you need 24 grams. Then now you're going to continue with your statement that you're going to dissolve 24 grams of sodium hydroxide into 300 ml of distilled water to make a 2 molar solution. So basically that's how you will follow. So if you are not given a volume, you leave it there at grams per liter. But when you are given a specific volume, then you do ratio and proportion so that you can be able to know the grams for that specific volume that you are given. So basically that's it from me for today. I hope you enjoyed the video and you could follow it. Up until next time, cheers.